So I hope you guys enjoyed it. I just want to show some photos. I didn't take a video today. I didn't have time to take a video. I was a little busy. But I showed it to you before. But let me just show some photos again. So there was the technical league that we did yesterday was just national. Okay? There was just South African teams. And they had to build robots and then do these little courses. And today and tomorrow it's like 14 international teams from all over the world at the same venue. Also doing robotic challenges. So this is I was a judge. So I judged these robots on their design, their technical aspects, and the functionality, and their robustness, and all kinds of things. And these are school students doing this. Alright, so they've got their little stalls and stuff. They set up their things. They're normally teams of between 4 and 8, 4 and 10 or so. This is the Coca-Cola Dome. So there was an automation fair on in the dome and this robotics competition. So there's different kinds of robots. This feeds the balls. It's all about little balls in the playing field, which feeds into, okay, there you can see the balls in the center there. So that falls out, it feeds into the robots, and the robots got to collect them and sort of put them in different places and so on, so forth to score points. Okay, and while this is on, there was an automation fair, South African or African automation fair. Industry-related products for automation control. It's a good place to network, to get jobs. There's a lot of students that works at the stalls, so you can ask them how they do it, how they get in there, how they get involved. A lot of sensors and stuff going on. Everything autonomous, everything to do with automation is there, and that was it. So I just wanted to show you guys. A lot of these guys were there yesterday. If you're interested in coming around next time, it's worth it. It's free. You get fed. You get nice food there, and it's really good. Okay, so guys, so we're gonna do the test. We're gonna do the memorandum sort of, but we're gonna do it in groups. You're gonna do it for me. I'm not gonna do it for you. So what I want to do is I want to go through the questions, and then you have to try and develop it in your group. Okay. Develop the question in your group, and then each group can have a chance to come and do it here. Because if you don't come and do it here, you guys don't do the work. So I need to do the work, give you a couple of minutes for it, depending on the difficulty of the questions from the test, and then you can come and explain it to us quickly, and then we can go through it. And obviously I'll help you with it. It's not going to be just you doing it. If there's stuff wrong, then I'll guide you. Okay? Okay, so you guys remember? Okay, show you this. Alright, so you shouldn't really use your textbooks at the moment. Don't use your textbooks. If you use your textbooks, it's going to be too easy. There's a lot of hints and stuff in there. The textbook you're going to use for learning purposes, not for this class activity. Okay, so just give me a second here. Hello? Yeah. Okay, so get some paper out, please, guys. And we're supposed to work in a group, and the whole mission for this is to get to know how other people think and how they interpret things. Okay, so I don't know why we'll just have to do that. I'll move it up in a second. I'll read it to you guys as well. Just get your stuff out. But what we want to do is each question we have to first derive a diagram for it, a sketch. Let's think about what is practically happening there. Okay? Okay. Now, so this is the first question that came out of the test. So to explain what a derivative is, an engineering professor asks a student to drop a ball, right? I'm not going to show the figure right now, from a height of 1 meter, by the time it impacts the ground. So it's a ball dropped from 1 meter high. Using a high resolution stopwatch, the student measures the time of impact as t is 0.452. So in other words, it releases at 5, when it drops, the time that has passed is 0.45 seconds. The professor then posed the following question. Now, before you attempt any of the questions, draw a diagram. What do you understand by the question? The diagram is vitally important. At the moment it's very easy and it looks stupid, it looks trivial to do, but if you get complex stuff, you cannot look at all the words, you will never find a solution to it. You have to draw diagrams for it. Okay? So let's get you used to it. So please, in your group, draw me what you think this represents best as you can with the most amount of information that you can, and then one of you will please come and draw it for me on the board. Okay, so I'll give you 2 minutes, 3 or 4 minutes. I'm similar to a lot of you that tries to do everything on my own. I do a lot of stuff on my own because I don't want to have other people help me, but it doesn't work. I promise you, if you're in a work environment where you're going to get fired, it doesn't really work. So please try and work with the other people, find out how they think and what their interpretation of the sketch is. Okay. Okay guys, I just want to get a proper sketch before we go on. I know some of you started on the other questions, I'm sure, but I want to get a proper sketch of this, a description in the sketch form, a diagram form, before we go too far with it. So, who would like to come and draw it for us and explain what the diagram is for? What is on the diagram? Come on. You don't have to come alone, you can bring some students with one, bring someone alone. Okay guys, problem. Guys, just quickly have a look at this. You don't necessarily have to draw a man or a dog or a car, whatever it's about. But it's good if that's the way you think about it and that's the way you understand it, do it. But you can represent it in a form without the man, it doesn't matter. However you see it. Yes, okay, now what about maybe Yeah, minus 2. And in what direction is that acceleration? Okay. Great. Good. Nice. Excellent. Thanks. Does someone have something completely different to that? Someone represent it another way? Okay. So, what you can also do is always write yourself 2 points. Guys, listen up quickly. Alright? The time was 0, because that's where you start. Okay? Okay, so, okay, now we can go on. What is the average velocity of differentiation? Later on, it's not going to be as simple as to use the equations of motion to get the answer. So this is to show that the application of what we're doing here can be solved via equations of motion and differentiation. So if you use equations of motion now, it's fine, but later on you cannot use them. And if they ask you to test, if this is under section differentiation and you do it with equations of motion, they're going to mark it wrong. Okay? So in the test for you guys, I marked it right mostly, the stuff that you do in equations of motion, but in the exam they will not, if it's under a topic of differentiation. They wanted you to differentiate.
So does it say that you have to differentiate?
No, the lecturer might do that. If they don't specify, then you can probably do it anyway. But a lot of the time, read all the questions just quickly first. Read them. And you'll see some of the questions you won't be able to answer by purely making use of equations of motion. Right? Then you don't use equations of motion from the start. From the start, go to differential rules. Okay, so please work out the average velocity. Okay, so just another thing is, what is the differentiation? What's the definition of differentiation?
It's a rate of change of something.
Okay, and the rate of change is normally, let's say it's got distance, right? So it's a differentiation of x, let's say x. Is the change of, let's say, the distance over the change in time. Okay? So in other words, it is S2 minus S1 over T2 minus T1. That's differentiation essentially. Okay. So what do you get if you differentiate displacement? If you differentiate the position, what do you get?
Velocity.
Okay, if you differentiate velocity?
Acceleration.
Okay, so please find the average velocity of the ball. You can remember this. Try and find the average velocity of the ball. Well, any way possible. Do it any way you want. Just try and find the average velocity of the ball. Throughout its motion, throughout its falling, the average velocity.
So, you want to use the equation that is like
Without doing what?
without writing without writing it in that form.
Yeah, you can just write it like that's fine. But that's essentially what you're doing. Because delta means the change in. Delta is the change in. No, okay. Just try and get the average velocity of the ball. Forget about this for now. Just try and get the average velocity of the ball, however you can. Okay? But thinking of differentiation, not thinking of equations of motion. Okay? Except 6.
Dessa boca pro Marol. Guys, look at quickly. Look here. Remember this, what I've done here? The average. Yes. Okay, so delta means let's call it x2 minus x1 over t2 minus t1. So what I'm asking him is, where's x2, where's x1 here? No, it's fine, I'm not saying it's wrong, I'm just asking, write down for me. Come back. This point, what is this point? Is that x1 or x2? Is that x1 or x2? Are you saying this is x2? Okay, guys, do you agree with this? No. Okay, why not? So what is the right? What is? So I got when you get the difference of taking a final minus one.
It's
original. So it's gonna cover after all the next, it's gonna cover one. So the final is just the extra. Right.
okay. Okay, but look at this. If x1, guys, look at this. If x1 is 0, okay, it's 0 there, and x2 has got a value there. It's something there. It's 1 meters. Okay. So this is equals to 0, and this is equals to 1. Then you've got 1 minus 0, which is not what you wrote. You wrote 0 minus 1. Do you understand that? It doesn't matter. If you choose to have your x2 there and your x1 there, then it's the other way around. Okay? Great. Now, another thing is, why do we do this? If you have this, if you have the ball traveling from there, yes, no, okay. So this is going to be 0.4, 5, whatever, minus 0. Okay, if you do it that way around, with this notation. Okay, guys, look at it. What is meant by the average is, if you have a measurement instrument, measuring velocity, and you measure there, the velocity when the ball's there, you measure when it's there, and you measure when it's there, and you measure when it's there. Let's say you've got 1, 2, 3, 4, 5 measurements, right? Then you take the sum of those measurements over 5. Right? That's the average. So that plus that plus that plus that plus that divided by 5. That's the average. That's what's happening. You see that? Okay? When you differentiate with a variable, with time as a variable, then you're going to work out one specific point.
Okay? You're not going to get an average. When you differentiate this, you don't calculate an average. You get a value at a specific point. Okay? Okay, great. So do you understand? Do you understand that concept? Okay. So C, the speed of the ball at impact. Now remember, speed and velocity, it's the same thing. Don't get confused with speed and velocity, it's the same. So what is the velocity or the speed of the ball at impact? So it's falling here. It's not zero at impact. Just before it hits the ground. I've got a micrometer before it hits the ground. What is its velocity there?
Average times 2.
So say again. Okay, wait. Work it out. Just deliberate your groups first. Don't tell me. Don't tell me. Don't tell me. Deliberate your groups and try and get the instantaneous velocity when it reaches just before it hits the ground. The instantaneous velocity. Sorry? When you work out the average velocity. Are you talking about on a road here? Now, if you have three samples, which are 3 velocities, you'll take those 3 velocities and you'll divide by 3 there. So you'll take the sum of those 3 velocities and you'll divide by 3 because that's your average. Okay, so I'm just saying, this was some of you struggled with this in the test. Okay, guys, let me just explain something because I think you're going to struggle with this a lot. It's something I'll teach you much later. Do you have an equation that describes the velocity of the ball? What is your? Do you have an equation? Do we have an equation? The velocity of the ball. Normally, you've got an equation. You're given an equation that describes the velocity of the ball. It's something in terms of a variable, in terms of time. We don't have that here. Okay, we don't have that. That's what I'm trying to say. There's no given equation. So you can derive that equation from taking this measured data. Okay, and in the example that I took this from, they give that measured data. So they put up an experiment. In the experiment, they log this data, they log that, they log that, they log that, they log that, and then they derive their own expression, quadratic expression for it. Okay, but we're not going to do that now. It's going to confuse you. So I'm telling you now that the professor says that the data used fits the following function. Okay, so y, which is the velocity, as a function of time. Okay, so y of t is equals to 1 minus 4,905 t squared. So for now, don't worry where this comes from. This comes from measured data, physically measured data. Okay? It was derived from that. Now, don't worry about that now. But this is given as your velocity equation for describing the velocity of the ball at any point. At any point. You see, you've got time there, so that's at any point. So now go again. So we try C.
That velocity.
Well, okay, okay, you're right. Let's not do that. Let's call it S of T. It's displacement. I gave you that. Okay. Now think about it. Give it 5 minutes and think about it. Speak to your friends about it and tell me, what do you think that is? Tell me what is. Do you think it's velocity? Do you think it's displacement? And how do you use that to get the answer for C, the velocity of the ball impact? Okay. Come on, guys, did you do it? Please help me with it. Guys, don't use equations of motion now. Use differentiation, not equations of motion. This is the equation that describes the position of the ball in any fire. Yeah, well, I want to show it now. So it's going to take you an hour to explain, but it is in the book. If you go into the book, you can see it there. It explains from measured data. I get this equation. So it's actually it's not a graph, it's an actual value. But normally, you have to leverage now. So no way. I always thought that it's to work to derive this equation. That's what if you look at the different form. You differentiate? Yeah. Okay, so come and show me. Come and show me, please. Okay, good. He's good at that. He's good at right. Okay, guys, while he's writing, note the answers or note the method of calculating, because this is your memorandum of the test. I'm not going to give you a memorandum. You're doing a memorandum now. Okay? Show all the steps. Show the steps. Yeah. How did you get to what you wrote down? Yes, it's given. Like I said, it's not for your level yet. Later on, you'll learn how to derive this from measured points. You can. This is not a dreamt up thing. It's valid for this problem. It's the correct equation for this problem. And you'll learn how to derive it from having points. And it's in the book, you can look at it in the book, they explain how to do it if you want to see. But for now, it's not about that concept, it's about differentiation.
Oh, here.
Guys, one is busy with that, go on with D, work on the acceleration. Okay, can you do C flat? Can you do, this is D now, can you do C flat? Come on, if you could have done C, D, you could have done C too. Okay, guys, do you agree with that? Okay, what happened to the one? Where's the one? Okay, then what happened to the one? Okay, that's fine. That's good. And did you guys do your thank you. Thanks. Right, so and D, do you agree with what you've done at G? Okay. Do you all understand what we're doing here? Simple. Right. Okay, so now it's not going to go that slow. Do question 2, and you can do as many as a question as quick as you can in your group, please. And then as soon as someone has all the answers, please come up. One of the other groups that hasn't got a chance to come and write them out for us. First start with drawing a problem. I first want that to be done on the board before you guys do B, C, and D. I don't want A, B, C, and D done all at once. Just A quickly on the board, and then B, C, and D afterwards. So please make a sketch, and then we'll go from there. So is this the ground then?
This is what's from here.
So is this ground or is it 1 meters or what is
This
that?
is where it's like from where it's from. Height from where it's from.
Okay, so what is the height of where it's from?
Yes. Oh no, oh.
Okay.
That's that.
Okay, read the question again, please. Read the question.
Me.
Yeah. Please, team, help him out.
Well, it's what I see thrown up with this velocity.
From where?
Oh, the height of, yeah, so it's, we have this height here, like from the ground. I don't understand.
Can someone help us? Maybe another for you, please. Yeah.
Oh, okay. So this is actually supposed to be here. So the ball is actually being from this distance.
Speak to your teammate and deliberate and see if this is correct.
No, so what you're saying is that this is actually supposed to be here.
I'm not saying anything.
Wait, yeah.
Read the question again. Actually, there's no trick in this. It's not a trick. Just read it. Don't just try and draw it. Just read the question.
Where's the? Okay, no, sorry. So this, what I wrote here is not supposed to be here. Because we have the distance from the ground to the ball, to the position of the ball. So that there are it's supposed to be here. That's supposed to be from the ground to here, but the ball is like moving from.
So right Okay, guys. So look at this. Be careful because it's easy to just look at it and think that the ball's not starting from the ground. Okay? The ball's starting at some position in the air already. Okay? Yeah, okay, alright. So this is ground. And that will describe, this is the ground level, right? And that describes the positional point for the ball when thrown at that velocity. Initial velocity, that's right. But he says the I, doesn't matter if it's V0 or VI. Okay? So you agree with that? Did you get the same diagrams?
Yes. So you hold this is gelijk, okay? En nog iemand op volgens u, tijdens van
All I'm saying is the ball, the ground level is not there, and the distance that it travels is that equation. That's not correct. You understand?
But that's why I'm asking. That's why I'm asking for you to think and tell me if it's right or not.
No, that's wrong.
Okay, so what is the actual level? Where is the level? That's what I'm asking. Get another team and come and draw it fast. Come and draw it fast, please.
So, they say all velocity increased from
wrong in the beginning, you'll probably have the whole question wrong. And you're going to waste a lot of time on that, having it wrong in the beginning. So that's why I said the interpretation
interpretation of the sketch is very important because some people had it a certain way and some other people had it a certain other way. If you don't have it in the right way, it's going to be wrong. And it's just drawing a sketch.
So, what I mean, sir,
Yes, I'm
Where's your maximum height? Where is your original height? Your original height.
This is the initial.
From the ground,
From the ground, yeah. That's how I understand the equation.
Okay, so let's quickly look at the first sketch. Look at this. What is the position of the ball there?
1 meter.
Okay? And then question 2 says, suppose now the ball is thrown upwards with the initial velocity of that. Then in figure 2. Okay? So what is the initial position of the ball?
sir, can you please go back to the question?
Sir, but
This is the question. This is the
No,
question.
no, like the full scenario.
Yeah, it's this. It's just this different document. I just retyped it. Yeah, it's just retyped it.
Sir, but I it says that the height of the ball from
But
the
sir,
ground is
okay.
given by that. Doesn't that mean that like the total, like the final distance that we get from
It's whatever distance for t that you substitute in there. You understand? So you can get all the distances for time.
sir,
So it's not the maximum height, it depends what t you put in there. If you put t max in there, then you'll get the maximum height. You understand?
that doesn't make any sense. Because like, you can have initial loss while it's on the ground.
But think about this, If you've got, listen to this guys, if you've got the ball on the ground level here, and let's say there's a piston or whatever, and you measure piston, and it projects it at an initial velocity of 4.43. So the moment that second it leaves the ground, it is going at 4.43 meters a second up. You understand? So it's lying on the ground, but there's a spring or whatever here, and when it's released at 4.43 meters per second. You understand? So it's not necessarily zero. They tell you it launches from the ground at 4.43 meters per second. Okay?
And if you substitute that 0.452 seconds into this equation, you get 1 meter.
Okay.
So the ball is on the ground at 0 seconds.
Okay. So did you guys hear that? So that's where the connection is between question 1 and question 2. Let me just get the sketch up. Question 1, the ball is falling from 1 meter downwards. Okay? Then in question 2, they say, suppose now. So in other words, it's the same scenario. It's the same scenario. It's just the second question. Okay?
But the sketch is a little.
Okay, wait. So tell them what you said.
If you substitute in the first question the 0.452 seconds, the ball took to drop from 1 meter to the ground. If you substitute that time in this equation, what's that equation? 4.43t minus, you know that equation?
It's there.
Yeah, that one.
Yes.
If you substitute that time in there, you get the 1 meter.
Okay.
Which tells you that the ball is on the ground. And then in 0.41 seconds, the ball travels from the ground to 1 meter.
Okay. So you understand that? So in that time that we worked out in the first question 1, it will be at a height of 1 meter. 1 meter. Okay? Is that fine? Does everyone understand? Yes. Okay. No, it's not wrong. That's right. Because if you replace it there, 0.45 and 0.45 whatever seconds, then this distance is 1, which is right, which is its height after that time. You understand? So I think this is where the problem comes in. Don't draw the ball there. Draw the ball here. Okay? Is that what's confusing you? Yeah. Just hang on, sir. Okay. Yeah. Yes. Yes. Okay. But what are you saying? Do you agree with that sketch or not?
I agree with what I'm saying.
Yeah. Okay, but so guys, the end result of this is that sketch is accurate. That's what you're supposed to. This is accurate. So in other words, yes. If you replace in 0 there, 0 and 0, so times 0 at the beginning, when you begin with your experiment, 0. If you replace 0 and 0 there, what is the distance? 0. Okay. So it starts on the ground for this question. It starts from the ground and launches up. And after 0.542 seconds, it is at 1 meter. Okay, cool. Let's go on, otherwise we're going to sit.
Oh, so I was right.
Okay, but I didn't say you were wrong. I just asked you, are you sure that's right? I just wanted you to explain to me why you thought that. Okay. So that's why, you see why it's important to draw some diagrams. Okay, people, I need someone to do maybe B and C together if they can. Okay, so we've already said it, but we have to calculate. I want to see someone calculate B plus this. Yeah, I have to be guys, please do B, C, and D while you're sitting in your group. Do B, C, and D. I'm not going to give you the answers. You must formulate your own answers for this. What is its velocity at its maximum height?
0.
Okay. But think about this, guys. If I look at this, if I throw this up, where its turning point is, what is its velocity? Up there. Yeah, it's 0. Okay, so it's. Yes. Look at this one and tell me if mathematically, I'm not talking about the answer is right, but mathematically what we've done here, is it all correct?
No.
Okay? Yes. So what is wrong? What do we need to add in there to make it mathematically correct? Just hang on, guys, I can't, yes? Okay, so this is important. They're gonna mark that wrong. So yes, you got to the right answer, but if you didn't say why is this equal to 0, because this isn't just always 0, because that's what he said here. It's not always just 0. In this case, it's 0 because there, where the turning point is, it's 0. So the velocity is 0 there. Okay. So you can also say here y prime is 0. Therefore, you can do this. So you set this equal to 0. That's how I can do that. Okay? I'm just saying, you got the right answer, it's fine, it's good. But you have to explain that, you have to say that. At least just write that. Y prime is equal to 0 because velocity is 0 at maximum height. Okay? And then at C, so what is the velocity? What is the velocity where it turns? Right. Okay, and D, did you calculate D first? Okay, you can finish the first go. Did you guys calculate D?
Yes, sir.
What is it? How much? Okay, have you guys learned how to do sine, cos, and trig? Sine, cos, and tan. Differentiation. Okay. So listen, come on. This is very short. We're just going to do this one. Do number 3 for me. Try take number 3. This is short. We haven't been so to say again. But it's just cos. So you say you've done sine. Okay? Okay, hang on. So then are the 2 first ones. Write down those 2 and then derivatives. Okay, cool. If you know it, then please remember it because he said you don't know how to do it. Okay, do you know that? Is it knowledge to you, common knowledge? Good. So please do number 3 for me in your group. Yes, okay. Come on guys, we're almost done. Just last question, please. Okay, guys, so please do this one. Question 3 in your groups. Last question in your groups. Please deliberate about it, talk about it, do A and B for me. Yep. Yes. That's all. Yes, so there was no potential differentiation at that moment. Has someone found the velocity of the trolley that can express it for you? Guys, which group hasn't come forward yet? All of you. So we start again now. So which group? Huh? Which group has found A yet? Have you found the velocity of the trolley yet? Come on. Okay, well, think about this. It's in terms of the variables. It's not a number. It's not 2.1 or whatever. It's in terms of the variables. Does someone have a clue what to do here?
Yes.
Do you know how to do it? Okay, will you please come and do it on the board for us so everyone can see it? Please. We're almost done, guys. Just another couple of minutes, please. Let's just finish this. Guys, do you agree with this? Please look at what is done on the board because most of you, or almost all of you, couldn't do it in the test, so this is very important.
Yes, we agree.
Okay, do you see where you got that from?
Yeah.
It's just from the table. There's no crazy logic behind it, not for now, anyway. He just used the table. Okay, thank you, thanks. He used that table. So you use the top one or the bottom one, it says cosmic. Have you guys worked it out? Are you fine with it? You guys are fine with it. And yellow, to the left, let's go. To the right, let's go. Okay? And yellow. And you guys, please attempt it. Please look what it's doing here and try and reproduce it. Yellow. Okay. Now, do you see what it's doing there? Yes. Please look at the effects. Okay, so all he did, no, hang on. All he did is he took this and he differentiated it again. Okay, so is that right? Yes. Is that right? If you look at omega is 2 pi, because that's given. Huh? It's called omega, not W. It's called omega. It looks like a W, but it's omega. Is that correct? Or is that correct? Yes. Are you sure? Okay, so come on, please fix it fast. Come on, guys. The quicker we do this, the quicker we can go. Let's fix this quickly. Is that right now? Yes.
Yes, no. the 2 by t, so it becomes 2 pi. Then the 2 pi multiplied by
No, that's fine. He just put it in bracket, just said that it's 2 pi squared, which is w squared.
It's fine, but it's the same thing.
Yes, no. I asked you if it's right. Is that right? That's what I'm asking. Hang on. Just wait, guys. Just listen. Yes. Yes, it's the same. I'm just asking if you're confident in the answer. And he just said he wants to represent it differently. He doesn't want to say 4 pi squared, he wants to say 2 pi squared, which is the same. Okay? Guys, I've got some homework for you, please. Write that down. Guys, listen up. These problems, please write them down, do them, and they're going to count like the previous homework. It's in your textbooks that I gave you. Okay? In your textbook, chapter 8.1, 8.6, and 8.8. Okay.
Is as much of a powerful need. When we're frightened, our thoughts are not